second virtual sensory session of our season. We will be jumping into the flights in just a couple of minutes, but before we do that, our next virtual sensory session will be on March the 4th. And the one after that is on March the 18th. I have not sent the invitations for those out yet. So if you're kind of like, I haven't gotten mine yet, they'll go out sometime next week. But I'll probably do just like I did this time and send both of them at the same time, just because we're kind of doing them every other week from now on. The reason we have a little bit of a space between this one and the next one is because of the VVA meeting. So VVA is on the 25th and 26th. So if you have not already done so, I'd encourage you to take a look at the program for that and go ahead and sign up and make sure you don't miss out on that opportunity for learning as well. As we jump in today, do be aware we're in the Zoom meeting platform, and we do that on purpose so that you have control of your own microphone. We want to make sure that you're able to kind of jump into the discussion at any point that you want to. So feel free to unmute yourself to ask a question or offer a comment or ask for clarification. We do ask that you keep your microphone muted when you're not actively participating in discussion, just so that we can't hear everything that's going on in everybody's background environment. And I will be recording today. I just pressed record because we do have a number of folks that sometimes can't make it to the in-person session. And so we put these on the YouTube channel for people to watch later. If you have missed any of the virtual sessions in the past and you're interested in looking at those, they're all kind of listed on that same channel. So if you need the link for that, I'm happy to give it to you. It should be on the front page of the website just as soon as I remember to put it up there. So hopefully by that, when I post this up there, I'll also post just the general link as well. So our chat is, the chat box is also active today. So if you have something to add or something you want to ask or make a comment and you just don't want to interrupt for whatever reason, first of all, feel free to interrupt. But if you don't want to do that, you can always put something into the chat box, and there's a little icon on the bottom of your screen that says chat. You can just type into there. Oops, I just made mine go away. There we go. So I will say that when we're kind of in the midst of discussion, sometimes I don't look at that as often as possible, or as often as I should. So if you've put something in there and I haven't gotten to it yet and you need me to take a look at it, just unmute yourself and tell me, hey, I've got this question. So let's go ahead and use the chat function to go ahead and introduce ourselves too. So if you want to just put in the chat who you are and what vineyard or winery or entity you're coming from today, and maybe myself and our co-host, maybe we'll do that audibly. So I'm Joy Ting, and I'm the research enologist for the Winemakers Research Exchange. And I'm here today with Mike and Nate. So Mike, why don't you introduce yourself first?
Okay, hey, I'm Michael Heny, Michael Shap's Wineworks, and I'm here presenting a micro-oxygenation trial on Cabernet Sauvignon.
And Nate?
I'm Nate Walsh with Walsh Family Wine, and I am presenting a Stabulation trial with Sauvignon Blanc.
Great. And I've also just put the sort of draft reports for both of those into the chat. So as we're talking today, if you want to know some of the nitty-gritty details of what's going on, we're going to go through kind of the general protocols for things. But if you want to know exactly how much enzyme was added and when, those PDF files should have that information for you. And then lastly, before we jump in, video is totally your choice. I do love to see your smiling faces out there. It helps us to feel like we're talking to real people. But if you are in an environment where there are things happening in the background that might be distracting to you or others, or if your internet connection isn't so great, you are welcome to turn that off as well. So that is absolutely your choice. But thanks to those of you who we can see your face, it does sort of help us to feel like this is more of a real meeting. So, okay, so with that, let's go ahead and we're going to jump right into our first experiment. So if you came onto the call in the last couple of minutes, you want to go ahead and get your wines ready. So we're going to look at the white wine experiment first. So you can go ahead and get those in your glasses, and we will jump in. So Nate, this was your experiment. So tell us a little bit about what you did and why you did it.
Sure. So we produce Sauvignon Blanc from 2 different vineyards, and have always bottled them as separate wines, as vineyard designate wines. And one goal that we have been moving towards, particularly with this vineyard, which is a vineyard called Twin Notch, is to just get a little more interesting aromatics or add some complexity to the aromatics. And we've been looking at different ways to approach that.
Your glasses on too much squint.
I was introduced to Stabulation through WRE in, I want to say 2019, maybe even 2018, where there had been a few wineries that did these trials, and myself and Kent, who works with us, who's on here, were really intrigued by what it did with Sauv Blanc and Rosé also, which we aren't tasting today, but we also did this trial.
That's not even adult.
Okay. So basically we're looking at the effect of Stabulation then on Sauvignon Blanc. And so just sort of in the interest of kind of defining our terms and making sure everybody knows what we're talking about as we talk through the trial, we'll look at Stabulation for just a minute and kind of what that protocol is and what we might be finding in those wines once we identify which ones are which. So Stabulation is really a technique where the juice lees themselves are stirred prior to settling and racking for fermentation. And it was actually developed in the Provençal region of France, as there was sort of this fashion of rosés becoming lighter and lighter. They found that their wines were, as a result, sort of lacking some aromatic intensity or some complexity, really because they just weren't spending as much time on skins and extracting aromatics that way. So they started to sort of do this juice lees stirring in order to try to extract some precursors for aromatics in just basically through the pulp itself. So really the idea is to extract thial and ester precursors. And so continuing to define our terms, when we talk about thials, these are a specific set of reduced sulfur compounds that really give tropical fruit aromas to our wines. They were first found in the 1990s, and they really weren't found before that because they're present in very, very small concentrations. So they're really hard to kind of measure chemically. And it was in the 90s they kind of developed the way to be able to measure that. But as they started to look around for thials, they were first found kind of as the thing that makes Sauvignon Blanc smell like Sauvignon Blanc. But since then, they've been found in lots of other places, Provençal Rosé for sure, but also in a number of other things. We did a trial last year with Thial from Rappahannock, did one with Chardonnay. Thials have become or have been identified in Chardonnay as being pretty important as well. And we also have them in our red varieties. So a lot of times we don't think about it necessarily with their red varieties, but a lot of the berry character that we get in red wines come from some version of thials as well. Another thing to realize though is that they're really found as precursors in our grapes. They're not very aromatic in our grapes themselves. They have to be extracted, but then they also have to be transformed into their aromatic selves through the process of fermentation. When we think about thials for Sauvignon Blanc, there's three main ones that are sort of definitional for Sauvignon Blanc. The first is 4-MMP, and that's the one that kind of gives us that New Zealandy like boxwood and broom, and in larger amounts it is identified with cat pee. So that's 4-MMP. 3-MH gives us sort of, I think of it as the sweet citrus character. So sort of that like sweet orange or grapefruit that you get when you kind of zest the fruit and get that nice punch of citrus. And then 3-MHA or A3-MH is basically, there's another enzymatic reaction of the 3-MH to give you a little bit different aromatic profile in the passion fruit and the gooseberry family. So when Nate's trying to do some stabulation on his Sauvignon Blanc, one of the families of aromatics that we might expect to see would be some of these thials coming out. But we have to remember thials are actually a larger family. So when we're talking about sort of the good ones, the ones we like, we're talking about the aromatic or the varietal thials. There's also reduced sulfur compounds that we don't necessarily like, and those are ones that we associate with our sulfur-like off odors. So cooked leeks, mercaptans, hydrogen sulfide, these are all still thials chemically, but they're kind of in a different group of compounds. We're not obviously trying to extract those in this case. So stabulation would give us more thials. Stabulation may also give us more ester precursors, and esters again are a very particular sort of chemical group. But as you see this big long list, they really different esters contribute a tremendous amount to the floral and fruit characters of our wine. And when we start to think about aromatic complexity, a lot of that complexity is coming from this really varied group of chemistry. So again, these come as precursors, and the yeast are the ones that are converting those. But if the precursor's not there, there's not as much for the yeast to work on. So in terms of sort of looking through the Stabilation protocol, we're trying to get precursors for these aromatics to be available for the aromatic profile of that wine. Okay, so Nate, tell us, how did you do your Stabilation?
Sure. So we, so all of this was picked on the same day, pressed to, ooh, awesome, pressed into a settling tank. And at that point, we, from that tank, separated out the Stabulation portion. And then the tank went through our standard Sauv Blanc protocol, which is the juice is cold settled and then racked to another tank for fermentation off the lees. And our Stabulation barrels were stirred anaerobically for 2 days. And then the same process. And then we allowed that to settle and then racked that to another barrel for inoculation and fermentation.
Can you, how did you do your anaerobic stirring? Were you just gassing with CO2 and paddle stirring, or what did that practically look like for you?
So because of the size of these trials, the control, so to speak, fermented in a stainless steel tank, a large tank, and the trial was in stainless steel barrels. So we kept the barrel full, or within about 2 inches, and we would drop dry ice in it multiple times a day with a like a loose bung on top that's weighed down. So it's ideally holding that dry ice in there. Granted, we would need to pop the top off to stir it, but then we would drop more dry ice in and put the bung back on. And we stirred it the same way you would stir a surly batonnage. We just used a barrel stirrer and got all those leaves back up there. And then we kept it we kept it, as you can see here, from 42 to 47 Fahrenheit during that entire Stabulation phase.
Yeah, so in the cool temperature during Stabulation is most of the time thought of just as trying to prevent fermentation. Like, you don't want fermentation to kick off before you have a chance to rack. So, and I would say that that's one the first time I heard about Stabulation, I sort of missed this piece of it. So there's the stirring of the lees, and then they're allowed to settle and it's racked back off. So the fermentation itself for both lots was from a clean racked juice. And so Nate was actually, he measures NTUs. His NTUs were like, I think 108 and 110 or something. So you corrected them to be like really close to each other.
We got it close. That's also Kent.
Yeah, well, good job, Kent. But in that sense, like that stirring is done for a couple of days, but it does settle and get clean racked before the actual fermentation. So we're not sort of picking up all the stuff that would happen if you had a really turbid fermentation. So.
Yeah, and I think, Joy, you had provided us with some temperature data for Stabulation, which we tried to follow, which seemed to suggest that the colder temperature, the quicker you could get like good Stabulation.
We'll look at that table at the end, so I'll put that table, but there is like a time temperature trade-off. So the colder it is, the longer it takes to actually extract off, just because you're dealing with like the kinetics of chemistry. Everything takes longer when it's colder. And so if you want to do a quicker Stabulation, you can do it warmer, but again, you just have to be really careful that you're not going to kick off fermentation so that you don't get a clean rack. So some of that has to do with the condition of your fruit. Some of that just has to do with how long you're able to let it sit in your own winery for your own production purposes. So. Okay, before we go any further, let me show you which one is which here then. So of the things that you have in front of you, if you are in, and I'll go ahead and read them off in case somebody's trying to look at this off of a phone or, is on audio for some reason. So if you're in group 1, wines 221 and 768 were stabulated, and wine 658 was control. If you're in group 2, wine 370 and 392 were control, and 358 was stabulated. If you're in group 3, wines 225 and 610 were stabulated, and 751 was control. And if you're in group 4, wines 659 and 248 were control, and 950 was stabulated. So hopefully you can rearrange your glasses there so you know which one is which as we go forward. So first we'll look at what the chemistry looks like, and then we'll come back and we'll talk about what these tasted like for you. So all of these started with the same juice. It wasn't split until after pressing, and so obviously the juice looks the same. And the fermentation kinetics here are pretty much the same. Nate, you were the one that pointed out you had a little bit of a longer lag phase in your tank ferment than your barrel ferment. And we can see here that's a little harder to control the temperature in the barrel fermentation. Just were you going kind of in and out of the cold room? Is that sort of what the
Exactly right,
situation
yeah.
was? Yeah. So that's probably just the, what happens when you're doing a small scale study. If you were to do this in a larger scale in your temperature controlled tank, we wouldn't have that issue, to have to worry about. The finished wine chemistry, the sort of gross chemistry on the wine is not very different between the two, and we really don't expect it to be. Again, the thiols themselves are present in very small amounts, and these aren't things that our normal chemistry will pick up. So we didn't see big differences there. So anything that we're kind of looking at in terms of sensory differences probably are due to that stabulation, not because we have some large difference in the wine chemistry itself. Okay, so with that, let's go ahead. Let's see if I can launch my, oops. Here we go. I'm trying to launch a poll. Here we go. All right. So with that, let me go ahead and launch this poll to see if you were able to distinguish between the wines. I myself was actually, when I did this blind, I wasn't able to tell the difference. But then also as you're sort of voting in the poll, go ahead and maybe write into the chat maybe some of the descriptive terms that came to you as you were tasting these wines. So part of our sensory sheet was kind of to say, what descriptive terms are you getting generally from these wines? And then if there was something that did sort of help you to tell the difference, was there anything that you that stood out to you for those of you that were able to tell the difference between those two? Which means I have to find my chat again. Here we go. Okay, so Rick picked up some petrol in the stabulated portion. Okay, other descriptors for these wines? Keep in mind. Okay, and Rick says the control had more citrus, more dried pineapple in the stabulated. And again, pineapple is actually one of those also that that comes up in sort of the thial, the family of thiols. In particular in Petit Manseng, we get that particular thial. That's part of what's driving the pineapple in Petit Manseng. Okay, lemongrass. Yeah, my guy wasn't able to distinguish the difference either. Okay, and Floyd felt that there was more aroma in the stabulated one. Oh, and we probably do have a typo. Let's see, 952 in my group 2 set along with Katrina. I'll have to get back to you on which one is which there. I'm sorry, I can't, because of what's on my screen right now, I can't see everything going here. Let's see.
No worries.
Yeah, so 392. Yeah, I will have to check back on that. Sorry. There's a lot of numbers that go through when we're getting these ready. So, and then Jesse feels like the control was slightly reductive on the nose versus the stabulated, and that might just be differences again in the fermentation, how long they've been out of fermentation, and that sort of thing too. So sometimes it's hard to control for all of those. When we do look at whether we were able to distinguish or not, it looks like we are not going to have a significant difference here between the wines if we're at 63% of folks were not able to tell the difference here. So this might be one of those examples where the stabulation just didn't make that much of a difference. It might have to do with what precursors were available. It might have to do with what aromatics you're already getting from your wine to begin with. Maybe there's just not that much to pump up. So Nate, what do you think? As you were sort of making the wine and even now as you're tasting it, do you feel like there's enough of a difference there to make you interested in doing this again, or?
I do think there's a little bit of a difference, although, I mean, we're in a position where we are able to taste this wine a lot relative to just tasting it right now.
Right.
We've been, for like the structure of Sauvignon Blanc, we've been moving towards earlier picks than what we used to do.
Mhm.
And so this is a little bit of we're trying to kind of keep it balanced aromatically with an earlier pick, which allows us to get like zesty or acidity. And we're also releasing the wines a little bit later. So we're trying to kind of retain a lot of that acidity. So no, I don't think it's really doing what we had hoped here. I think you could get just as big of an aromatic difference or a bigger one through like yeast choice or, Lee's work during the fermentation, things like that. So I think we'll probably move in that direction. But I will say, and we can't taste everything, but the difference we got in our rosé, we will continue with that experiment and do it again because it pushed in a really interesting direction.
Yeah, I was going to bring that up. I feel like when we talked about this right after harvest, you and I tasted both your rosé and your Sauvignon Blanc, and I felt like your rosé had a bigger difference. I think we weren't able to catch that before it got blended.
Yeah, we had to blend it.
Blended through. But I think that was one that showed a little bit more difference to me along the way. And Shai asked a really good question: would the length of Stabilation change the sensory? And did we maybe just not have enough time? And I think that's a good point to think about. Like thinking about that table that you were looking at, Nate, before so the first time I knew about Stabilation in Virginia was when Lefort did the Stabilation trials. And I think it was in 2016. And this table actually comes from Lefort for when they were doing those trials. And this gets to your question, Shai. I think that the longer you stabulate, there is that idea that you kind of do get more off of it. But again, the longer you're stabulating, the more risk that you're taking in terms of having anything happen, like fermentation kickoff, if there's any botrytis in there, and getting some oxidation in the wine. And honestly, sometimes it's just a production logistical thing. I'm not sure I would have ever been able to sit anything stirring in a tank for 3 weeks before racking it and getting it started to ferment, just because I didn't really have extra tanks around. So, I think that's another possibility of kind of trying to pump up the effect, is to either do it longer or to do it warmer, to see if you can sort of get that extraction to happen. So Mark is asking, what were the impacts on the rosé? Nate, are there some descriptors that you can come up with for that? I have my notes are at another part.
Yeah. To show my vocabulary, my wine tasting vocabulary to everyone here, it was a much more fruity tooty, a lot more kind of like almost carbonic, like bubblegumish quality. But for rosé, we really liked it. We won't do it for a full lot, but we'll trial it again this year with rosé. But it was very kind of outspoken fruity.
Yeah, and I would say I think that you really pumped up kind of those berry notes to it a little bit, and that kind of gets to, and in that I would agree that tutti frutti is a good word there. Like I think of it sometimes as Kool-Aid fruits too, like some sort of artificial, like red Kool-Aid. That's what I think about.
my concern is if it's too much in that like confected aromatic, like I'd rather not have that. But if it's a blending piece and it adds this like kind of, we're just sort of looking at it that way. But it theoretically seemed like it could go in like a Kool-Aid kind of confected world.
So as we sort of wrap up with the Stabilation trial, then there are a couple of just really practical things if you're thinking about doing Stabilation that I think are really important to say at some point when we think about it. And the first is that if you're going to do this, you really need to start with good quality fruit. Nate mentioned that this was a relatively early pick of Sauvignon Blanc, and they sort of do a nice job of putting notes on their harvest sheets about the condition of the fruit. But I think one of the reasons to harvest early in this case also was just to make sure it was super clean fruit. You don't want to bring anything in, again, that has the potential to kind of have lacase in there and you're stirring it on the lacase. That's not a good idea. Or any microbial spoilage. So you do want to make sure you've got good quality fruit, just because you're going to sit it around with the lees for a while. And again, just remembering that most of these precursors and the aromatics themselves are very sensitive to oxygen. So at every step of the way, this is really kind of that really protective oxygen or antioxidant environment. So you want to make sure that you're protecting your juice with, with dry ice or with gas. Most companies at this point have some form of glutathione product that a lot of people use. Also, that's just another scavenger for oxygen along the way. Making sure that anytime you're doing your mixing, that's as anaerobic as possible. So either with dry ice or with CO2, because otherwise you're kind of mixing oxygen in there at the same time and working against yourself or negating the impact that you're getting from the stabulation itself. Keeping the wine cold, again, to prevent fermentation. And then also just making sure you're getting the most out of what you've extracted there. So using Thial producing yeast that have more enzymes to be able to release these sorts of things. And then again, during aging, doing all of the things to be reductive in aging as well. So making sure you maintain adequate SO2. If your SO2 levels get too low, you've got some oxygen in there and you're going to start to convert these thiols to non-aromatic forms. And again, stainless steel and top tanks do a better job than, for example, barrels. There's just a little bit of oxygenation that happens there. So we have a couple of questions that have come into the chat. John is asking, does the stabulation change your first SO2 dose? So if you're going to stabulate, are you thinking about being more protective on the front end, or in this case, were you kind of the same?
We were the same, but I can't remember what it was. It was probably 30 parts.
I think it was 30, but
which is the high end of what we would do for Sauv Blanc. I wouldn't be comfortable going lower than that. I mean, really it's 3 to 4 days that you're just leaving this juice, because it's 2 days being stirred and then it needs to settle for another day. So that was a worrisome period for me. Even though it's cold, it's still, like Joy is saying, it's just getting oxygen at that point. So we did not change it, but I wouldn't go low, which we sometimes go kind of low. I see the other question. Did we use tannins? Like a product? No. Whatever tannins were in the grapes.
But Lee, that is another thing that some people will use for antioxidants. So some people will add glutathione products, some will add tannin products, all of that in the sense of being some form of oxygen scavenger. So. Okay, so before we wrap up, is anybody else in the audience, has anybody else done stabulation? Maybe we can use the raise your hand feature. So if you look down at the bottom, you should, oops, I lost it, sorry. Let's see, I can't seem to find mine. Mine is not popping up now. There's a raise your hand feature where you can sort of just raise your hand in the reactions if you've done stabulation before. Okay, so Katrina's done stabulation. Anybody else? Rachel has done stabulation. Okay. So so Katrina, can you tell us when you did yours, and Corey has done, I see Corey's hand is up. And Sharon has done some. So any of those folks actually, if you're willing to unmute yourself, just tell us, how did you do, like, was yours what variety was it with? Was it in a tank? And how did you get your stirring done? Because these are the questions I have about it.
Well, I can say I've only done it once. It was last year, no, year before last, actually, at this point. And it was Sauvignon Blanc. It was Virginia Sauvignon Blanc. And we did it in a stainless steel tank. And actually, the way we managed to stir up the lees was just by hooking up gas lines to the bottom of the tank and utilizing gas to stir up the juice. That way we prevented oxygenation and also managed to stir it up pretty well.
Great. Okay, any of our other folks that have done stabulation, did anybody do their mixing a different way than that? Or was it mostly with just adding CO2 gas in? That's most of what I see, but. Okay. Okay, so any other questions for the on the Stabulation trial? For any other questions for Nate before we move on to the second flight? Okay, so let's go ahead and transition then to the second flight. So you can get your, if you haven't already done so, you can get your wines out. I'll do that as well. And this is flight number 2 was Michael Heny's experiment. So Michael, do you want to tell us a little bit about what your experiment was and what you were hoping to accomplish here?
Absolutely. So yeah. So this experiment was using micro-oxygenation on a Cabernet Sauvignon from Carter's Mountain Vineyard. I know some of you in the audience have worked with this fruit before, probably more than I have. It's my second year working with this fruit. And I understand in the past it's had some reduction issues to it. And in 2019, I felt like the tannins were a bit unresolved. So I was curious about using micro-oxygenation to maybe see what effect it would have on some reduction in the wine. And so, yes, it's mostly from that angle. I've done micro-ox fairly extensively in the past for more structuring goals, more intense tannic wines, say Tannat or Touriga Nacional is not super tannic, but it's more of a dense red. So this was really a new use for the tool for me as compared to what the work I've done with it in the past. Yeah, so that's what we were doing.
Great. Yeah, and I actually have worked with this fruit as well. And my experience, Michael, would be that it does tend toward reduction, certainly. So I'm excited to see this potential tool being used here. So again, just to sort of make sure we're all on the same page before we sort of get to tasting the wines itself. As Michael said, when we think about micro-oxygenation, there's actually a number of different things that one might use micro-oxygenation for. Basically, it's just a technique where you're intentionally adding small amounts of oxygen in a really measured and controlled way. That could be to make changes in color stability. It sort of is thought to help color stability. It can help in some aroma difficulties. And as Michael said, sometimes it can be used in the structuring of tannins as well. And I think in order to kind of understand how it's doing all of those things, for me, the way I tend to think about that is to sort of go back and just think about the different aspects of that and how oxygen is interacting with those things. So the first of that would just be, how is it actually helping to soften the tannins or give us a little bit more refined tannin along the way? And I think the way that I kind of ended up thinking about that is just remembering that, tannins are polymers, so they're really big molecules made up of individual subunits kind of all hooked together through bonds. And we get those from our grapes, from our skins and our seeds. But once they actually hit the environment of the wine, the acidic environment of the wine actually starts to kind of pop them apart. So the individual monomers that are making up that big polymer kind of start to come off. So you end up with some monomers and some smaller polymers in your wine, in your fermenting juice and in your wine. But they don't stay that way either. Eventually they kind of come back together in energetically more stable forms to form large polymers again. But the way they arrange themselves in those larger polymers is not the same as what they started out with from your grape tannins. So you're using the same subunits, but you're putting them back together in a different way. And when we think about how we're putting them back together, there's a couple of things that kind of influence how they get put back together. One of those is the presence of anthocyanins, and the other is the presence or absence of oxygen. So if we kind of think about that in our little cartoon here, if the little yellow dots are the subunits that will make up our tannins, and the little red dots are our anthocyanins, in order to kind of come back together in that condensation reaction to form a polymer, they have to hit each other at the right configuration to be able to form a bond with the right energy. And the way that tends to happen is it's sort of constrained how many different ways it can come together and form that bond. So the way it tends to bond is in relatively linear structures. But once one tannin monomer binds to another tannin monomer, it actually makes that sort of dimer more likely to make the next bond. So it's sort of this chain reaction starts to make it more likely to bond the next time. And that's true until it bonds to an anthocyanin. So if an anthocyanin happens to hit in the right three-dimensional structure, it also can form a bond there. But when it does that, it makes it much less likely that it's going to bond again later. So it essentially kind of caps off the growth of the polymer itself. And all of this will happen without any oxygen around, but it is really slow. It's kind of what's happening, for example, during bottle aging. Your tannins are still polymerizing and changing in a reductive environment, but it's fairly slow. If we introduce oxygen into the mix, there's two important things that happen when oxygen comes into the mix. The first is that it just sort of catalyzes that beginning reaction happens faster. So if there's oxygen around, it can kind of kick off that polymerization reaction so that it's going to happen faster. But the other thing is when you're adding oxygen in the wine, it's not just hitting the tannin monomers, it's also hitting just everything else that it can find in the wine. And the most likely thing it's going to hit is ethanol. And when oxygen comes in contact with ethanol, it reacts to form acetaldehyde. And we think about acetaldehyde like, when you have that barrel fermentation of Chardonnay that's been going on too long and you have that like kind of bruised apple kind of thing, that's acetaldehyde. It's the same thing here, but it's actually useful in this case. Acetaldehyde is going to help to kind of form a cross-link between our monomers to hold them close to each other, so they're more likely to form a bond. So that bond's going to happen faster. The other thing is that it's going to allow that bond to form in more diverse ways. And so instead of just getting, this relatively linear relatively linear molecule with a few branches, you're going to get more diversity and more flexibility in that bonding. And the reason that matters for sort of structuring your tannins is that that basically the perception of astringency in our tannins comes from all these little sites on our tannin monomers that interact with the mucus in your saliva to give you lubrication. And when the tannin interacts with that, it's going to precipitate that lubrication. And so something feels astringent. When we look at, and again, our tannin are under reductive conditions, we get these sort of linear molecules. So all of those binding sites are available. When we get these tannins that are formed with these acetaldehyde cross-linkers with these different bonds that are allowed, it's more of a globular structure. And so not all of those binding sites are available. So the same amount of polymerization just basically feels like it's less astringent because there's fewer of those sites that are available to bind to your mucus. So that's sort of why, you can kind of help to make softer or less grippy tannins by adding some oxygen in with the wine. But this also sort of helps with color stability. And that's one of the first things that people noticed about microoxygenation is that it tends to have more stable color. And really that's because once fermentation is finished, the anthocyanins sort of have a time clock during which they're just going to start getting lost. So they're either going to, first of all, they just become less soluble once fermentation is over. Anthocyanins normally have a sugar attached to them, which makes them more soluble. Through fermentation, that gets cleaved off and consumed. So it's less soluble just because it's lost its sugar. And then when you put that in alcohol, it's even less soluble. So you're sort of just going to have this loss of your anthocyanins. When you've got oxygen around, those anthocyanins are going to bond to your growing polymer of tannin faster before you've lost as many of them. So you're just more likely to keep them. But so that's sort of that piece of it. Now there is sort of a danger there in taking it too far. If you keep adding oxygen and keep adding oxygen, you can sort of build this tannin polymer so it gets so big that it actually kind of overcomes its own globular structure and it just becomes super grippy and tannic again. So that's one of the things in managing microoxygenation is sort of getting it far enough without bringing it too far along the way. And the other thing is if that tannin gets super big, it might precipitate out and it will take its anthocyanins with it. So you can, again, if you take it too far, you can see a loss of color instead of the gain of color with microoxygenation. So that's sort of the tannin color piece of that. The reduction piece of that, or sort of these reductive odors, which is really what we're talking about more here, is more straightforward in terms of the chemistry. You know, we talked earlier about the thiols that are these reduced sulfur compounds that have lovely aromas for us. There's also reduced sulfur compounds that have not lovely aromas for us. So for example, hydrogen sulfide, this smells like rotten eggs, but if you add a little bit of oxygen in there, basically the oxygen is going to steal some of those hydrogens off of the hydrogen sulfide and leave you with elemental sulfur, which is odorless. And so a little bit of oxygen can sometimes sort of shift that hydrogen sulfide smell to be an odorless product. Another sort of odoriferous thiol that we can deal with would be methyl mercaptan, or any of the mercaptans. And again, you can see this sort of SH in there telling us it's a thiol. These are the ones that sort of have the skunky, funky odors to them. So skunk, some rotten eggs, some cabbage, but really if it has that like really sharp skunkiness to it, probably you're dealing with a mercaptan. In this case, a little bit of oxygen doesn't necessarily make an odorless compound, but it does make one that's essentially less offensive. So it's one that more in the onion garlic family than the skunk cabbage family. But the other important thing here is it shifts the detection threshold. So the detection threshold for mercaptans is really, really low. Those detection thresholds are between 0.2 and 2 parts per billion. So a very little bit goes a long way in terms of being able to pick that up in sensory. Whereas when we're kind of thinking about our dimethyl sulfide, for example, that's more in that order, about 12 parts per billion. Still, that's still pretty low, but you've actually given yourself almost an order of magnitude along the way there. So that's sort of those reductive things. And then the last one that people will use micro-oxygenation for is to deal with some vegetative aromas. So when they first started testing micro-ox, they noticed that they would do these experiments with micro-ox, and the control wines would score higher for vegetal and herbal than the micro-ox wines. And when we think about vegetal, we always think about methoxypyrazine. And here in Virginia, that's something that we certainly do worry about, particularly with Cabernet Sauvignon in Virginia. But the folks that were working on this, Bruce was one of the folks working on this. Basically, they kept sort of doing these experiments and testing for methoxypyrazine, and the pyrazine was unaffected. Like the pyrazine was the same in the control versus the treatment. And so they were like, why are we getting this consistent shift in vegetal? And it turns out that it's really because our perception of vegetal includes pyrazines, but it also includes some of these thiols. And so as you micro-ox and take some of these thiols out, the overall perception of veg still sometimes can go down, even though you're not affecting the methoxypyrazine itself. So all of that, those are all different reasons that you might do micro-ox. And really, when you're doing micro-ox, you don't get to choose which one it is. The oxygen goes in there and it does all of those things. But depending on when you do the micro-ox, you might get more of one effect versus the other. So again, for structuring tannins, you kind of want to get at it right after alcoholic fermentation. But for some of these reductive things, you can certainly get at it after malolactic, which is what this particular experiment did. But either way, you do want to kind of, again, make sure that you're going far enough, but not too far, because if you go too far, you can get that overpolymerization of tannins. You can just get some oxidation or browning. And also, anytime you're putting oxygen into the wine, you might be feeding some of your oxidative spoilage organisms. And so there's sort of risks and rewards along the way. All right, so that's a whole bunch of kind of why you might want to do it. Michael, why don't you tell us how you set up your experiment?
Okay. Yeah. So So what we did here. Thanks, Joy. Like the graphic here. Yeah. So we destemmed the wine into a combination of tanks and bins. So it's a combination of tank and bin ferment. I know the data is in here somewhere on when different ads were made, but we think I added some yeast the next day and did fermentation. So pretty standard. Twice a day pump overs on the tank wine and twice a day punch downs on the bin wine. Then at following dryness, they were pressed and combined at that point to tank. And then I think they sat in tank for a few days. Probably part of that was there was a bit of maneuvering in order to free up the tanks that we needed free to do the experiment in. And fortunately, we had enough volume to do 2 full 2,100 liter tanks, because a couple of things were important. It was important to have the same wine, so just have that wine and not have one of the tanks topped with something else. It was also the tanks had to be full. So yeah, there's a bit just trying to line all of that up. But when we saw that opportunity, rack to tank, did a clean racking to tank, and started the trial just a few days after that. With the micro-ox unit that we have, pretty much what it is, it's just a kind of a regulator and a timer that sits between an oxygen tank and a sparging stone that sits in the bottom of your tank. So I don't know if anyone can see this very well, but it's it's just sparging stones that it would allow the gas to come out to the wine. They recommend. I can't remember, Joy. Maybe you remember the minimum tank wine height that they recommend having, but it's like 7 or 8 feet or so. So you want to have a minimum amount of wine height. So we did have that. But yeah, with our micro-ox unit, in order to run it continuously, which would be the preferable way to do it, because you would have these smaller continuous doses going in all the time, you would need a minimum volume, about 4,000 gallons. So we weren't there on this one. So what we did instead is we would turn it on for a certain number of hours and then turn it back off. So kind of played out that every other day we would turn it on for about 8 hours or so, and we were tasting it daily. So yeah, and we did it at a fairly moderate rate, so 5 milliliters per liter per month. I believe, Joy, correct me if I'm wrong here, but I think like a barrel, I think they say that does like 1 mil per liter per month, something like that. And
I would have to look up those numbers.
Yeah. So just the point is, we were at a low level, and we were at a low level because we weren't trying to do a lot of structuring here. It was more just kind of looking at the effect on the reduction. Fairly early on, I didn't feel like the wine was hugely reduced, but fairly early on day 3, I saw perceived a significant difference between the two, and I felt like the kind of micro-ox was having a positive effect on the aromatics of the wine. I wasn't hating the control, but I was really liking the kind of bright red fruit that I felt like the micro-ox was bringing to the wine. And yeah, and that kind of stayed. So kind of looking back on it, some of my questions would be on day 3, was that kind of the end at that point? So there was a difference in the wine, but maybe not anything that further that happened. I wasn't able to perceive it as easily as that difference in aromas that happened fairly early on. And then we I think kind of the tough part about, say, micro-ox maybe in my mind is similar to extended maceration. So extended maceration, when is that aha moment? So is it day 20, day 30, day 40? I know we've all been there, kind of tasting, looking for that aha moment, and it's not always so clear to me. And in a similar way, I'm happy with the result here, because I definitely didn't go too far. But until you go too far, you don't really know where that line is.
Yeah, I think that's a really good point, Michael. I looked back at some of our previous WRE experiments that looked at micro-oxygenation. One of them was one that I did when I was still at Wineworks and tonight, and we weren't able to tell the difference between the wines. And so I think in that sense, I didn't go far enough with it. And I think some of that does have to do with kind of what your goal is. So, thinking about if you're trying to structure the tannins, you're almost afraid to go too far, because Bruce has a really nice line in one of his papers on micro-ox that it's sort of like piloting an ocean liner. that like you're starting, when you're trying to structure tannins, you're starting off this chain reaction and you don't know, like you kind of have to stop it before you get the full effect of the chain reaction. Whereas I think when you're trying to treat reduction, you get, it's not quite that big long of a chain. And so maybe it's not quite as hard to make the call as to when to stop it. So I do want to make sure that it was a nice experiment in the sense that we had two sort of twin tanks right next to each other. They got the same number of rackings. They got the same amount of, they were top tanks the whole time. So in that case, I feel like the oxygen exposure, the only difference in oxygen exposure between these two really was that micro-ox. So let's go ahead and tell you, let's go ahead and look at which wines were which so that we can start to talk about our results here. So if you were in group 1, wines 263 and 534 were control, and wine 347 was the micro-ox. If you're in group 2, wines 427 and 200 are micro-ox, and 418 are control. If you're in group 3, wines 847 and 220 were control, and the 796 was micro-ox. And if you're in group 4, wines 555 and 315 are control, are micro-ox, and 203 are control. Sorry, so many numbers. So let me go ahead and we'll look at the chemistry really quickly. We wouldn't necessarily expect to see too much difference in chemistry. These were exactly the same wines off of the press. And again, our gross chemistry is not really going to we shouldn't expect to see any big differences in the gross chemistry, and we don't. We did have a little difference in color intensity, but at the time that we took that particular number, there was also an SO2 difference between the wines because that was taken right after micro-ox. And at this point, those SO2 numbers have been evened out. So we'll talk about what your perception of that color is in just a minute. But when we looked at the phenolics for these wines, again, we did not see big differences in the phenolics. But again, that wasn't really the aim here. The aim for this particular experiment really was that sensory, not to really be doing much in the phenolic realm. Although you may have picked up some differences, which we'll talk about in just a minute. So, but again, we really wouldn't expect to see too big of a difference there. So with that, let me go ahead and launch the poll. Were you able to tell the difference between these two wines? And again, if so, maybe you can write into the chat, or at this point, you can feel free to unmute yourself as well to say, were you able, what are some of the descriptors you came up with for these wines? And also, was there something that helped you to be able to tell the difference between those wines? So John felt like there were some softer tannins in the micro-ox. Oh, I'm sorry, my poll is not launched. There we go. Do you see the poll now? Hopefully it's launched. There you go. Yeah. So John felt like there were some softer tannins in the micro-ox. So that would be an expected result to some degree. And I do think we had some grippy tannins in the at the beginning. Nate feels like the micro-ox is aromatically cleaner with a softer body. Nate, do you want to clarify this aromatically cleaner?
Yes, for me, the control comes off a little reduced, and the micro-oxes are real nice, clean and fruity.
Yeah. Camden feels like there's a lot brighter fruit in the micro-ox, higher expression of fruit on the micro-ox from Shy. So again, we're kind of seeing what, I think a lot of times that reduction, that the fruit is there, but it's just being kind of covered up by some of that reduction. And especially because we have such low threshold of detection for that reduction, we really kind of keeps us from smelling some of those other fruity characters. Less bitter on the micro-ox, okay? And better fruit on the micro-ox. So it seems like the micro-ox is a popular choice here. When we look at whether people were able to tell the difference or not, let me go ahead and do this and share the results. It looks like about 63% of people were able to tell the difference in these wines. I was as well. And so that will end up, when I do the statistics, that will end up to be a significant difference. So, considering what the winemaking goals were, again, that idea of sort of dealing with some of the reduction. And Michael, I think you also, when we first talked about it, this is a wine that probably will get bottled pretty early. And so maybe it doesn't have as much time to just sort of work itself out in a barrel. So, you know, in terms of those of you that were able to tell the difference, do you feel like we accomplished the winemaking goal here? And which one did you prefer? And Michael, I'll ask you that question. How do you feel in terms of using this technique for this particular lot of wine? And, you know, what's your preference?
Yeah. So I was very happy with the micro-ox treatment on this wine, especially with you know, this wine's going to go into bottle in the summer, probably be released in the fall, so it's going to be an earlier, easy drinking red. So yeah, I'm very happy to have been able to do an intervention earlier on that has stayed with the wine and not negatively impacted it. So, you know, part of the worry with, you know, adding more air earlier on is you're speeding the wine forward, so maybe you're going to go too far. So I don't feel like that at all. So yeah, just thinking forward to next year, if there's an opportunity to do all of it, you know, a lot of it's just kind of tank space and timing. If there's appropriate tank empty at the time, and we can, you know, kind of let it sit in that tank for a few weeks, then yeah, I'd love to experiment and would have a little confidence in, you know, perhaps pushing it a little bit further. But I think that this range was successful with the vineyard and the vintage. Of course, next year's vintage could be different, will be different.
Although, again, having worked with this fruit, it is a common problem with this particular lot. So, so I think you may have a good approach in dealing with it there. So it looks like our poll results are kind of seem to agree there, in the sense that we, by and large, people did prefer the micro-oxygenated wine at this stage of the game, and also thinking that sort of did a good job of dealing with the sorry, I'm not sharing. I'm looking at the results. I'm not sharing them with you all. That's not very nice. So it looks like they did. Folks did feel like this did a good job of accomplishing those winemaking goals. So, Michael, do you think you might use your micro-ox for some other purposes? Do you have other lots of wine that you're like, you know, this might be a useful tool for some of the other things you've got in the cellar?
You know, one thing I was curious about was definitely run into some rosé lots that can get reduced, and if, you know, some certainly a lower level than we did on this red, just kind of how that would play with the wine, and maybe address some reduction issues in rosé a bit earlier on. Yeah, so that end of the thinking. And then, you know, I think we work with vineyards a number of years, or different growers. You might know where to anticipate that a place where a tool like this might be effective as well. So yeah, I definitely have some lots like, oh man, wish I'd had a chance to micro-ox that. I'm gonna have to deal with it in a different way now.
Yeah, and I think, you know, it does come with those logistical challenges again of just making sure that the tank, there has to be a certain tank height in order to, the idea is that you want all the oxygen to actually be bound up before it gets to the top of the tank, so you don't have like this layer of oxygen on the top of the tank to get oxidized. And so there is, I think your 2100 tanks were the smallest tank that sort of had that height to them when I looked at them last time. So there's that too, that you have to have the appropriate lot size to be able to get that done. They do make accessories that you can do these in barrel now. But again, that would be a whole nother purchase in terms of the box itself and the other part of it. So
yeah, and why I like the tank and the larger volumes is there's more room for little small errors there. So, you know, there's just a larger volume to buffer it. So, you know, I would become more and more hesitant as the smaller the volume got, because I feel like the room for error is much smaller. It's easier to screw up with a smaller volume on it.
Yeah.
Although you're messing up a smaller amount of wine, but you know, as you get confidence with the technique, you've got more buffer room with a larger volume.
Definitely. So, in the audience, has anybody else done micro-oxygenation? Maybe you can raise your hand again, and maybe tell us what you micro-oxed and why. So what are some of, any of the other reasons that people might micro-ox. Again, I have micro-ox to not, pretty much for kind of that accelerated aging portion of it. We had a client that kind of wanted to do a little bit earlier bottling of Tannat. And so the idea was to try to get that acceleration in the tannin and the tannin polymerization. So anyone else done micro-ox out there? Jonathan's done micro-ox, he's just not. We do have two former, yeah.
Can you hear me?
Yes, I can hear you. Thanks, Jonathan. Yeah, you did one through the WRE at least, but you do it more than that.
Yeah, I've done a lot. I do some every year. I've done both macro and micro, and for the same reasons Michael was talking about, to reduce herbaceous nodes to it, move wines a little bit faster if it's an early release wine, and I really like it. Did anyone notice any color difference in any of the wines?
I thought I saw a color difference, but I wasn't super careful about measuring them out. But it seemed like in mine that the micro-ox had more color.
More color, right?
Yeah,
I did too. I found that like pretty drastic. I got a little more yellows and oranges, and then on the micro-ox I got a lot more, darker red in color. But I think it works well.
Yeah. Yeah. So when you do your micro-ox, Jonathan, when in the process are you doing it? Are you doing it post mallow?
So what I've done, I've moved more towards adding on more oxygen early on. So I'm actually doing it during ferment. I'm, in more of the 30 to 60 milliliters per liter per month. So very heavy oxygen, and I taper it off, obviously, way down after mallow, but going really heavy earlier on, getting a healthy ferment, and then the ideal time is just before mallow. So if you can kind of if you can add a significant amount just before mallow, then you get better effect.
Yeah, and one of the other things I read about doing it before mallow is that when you sort of you're producing this acetaldehyde, and then your malic acid yeast are actually going to eat your acetaldehyde, so you don't end up with more aldehyde at the end that's going to bind up more SO2 as well. So it sort of gives you a little bit more buffer in that regard too.
Yeah, exactly.
Yeah. Well, thank you, Jonathan. Thanks for sharing.
Yep.
Okay, so any other questions before we get going? It looks like BJ asked, did we talk about aging potential on the wine after micro? That's kind of a trick question, and it's for two reasons. So you can do micro-oxygenation the way that we've been talking about it in order to kind of get the tannins to kind of go a little bit faster, in which case you've sort of sped that up. But you can also kind of make some decisions in terms of when you're doing this to try to actually structure the tannins more to get longer aging potential. And it has to do with kind of playing with the redox potential of the wine. I will be doing a newsletter on micro-ox in the next month. So I might try to touch on that in a little bit more detail in that newsletter, because it's kind of, that's maybe not quite the deep end of the chemistry, but kind of getting close to that. So BJ, I'll try to address that in the upcoming newsletter. Okay, any other questions or comments for our experimenters today? All right, so with that, let me go ahead and make sure to thank the Virginia Wine Board for funding the WRE and making all of this available to us during the year. Thank you to Nate, to Walsh Family Wine, to Michael, and to Michael Shop's Wineworks for getting your experiments done and for being willing to share your insights and your wines with us today. We really do appreciate that. And thanks to each one of you that came to our discussion today and filled out your sensory sheets. All of that sensory data that you fill out becomes the statistics that we can use to basically come back and say, did we really see a difference or not? Each one of us got to experience the wines, but also what was the group consensus along the way? So thank you for doing those as well. And I will go ahead and let you go. Do keep an eye on your email. Like I said, sometime next week, you'll be getting the invitation for the next couple of sensory sessions. We will have some on whole clusters and carbonic. We have some on nutrients. So some really kind of perennial questions that we all sort of deal with at one time or another. So keep an eye out for that. So thank you all so much for coming today. I really appreciate it. And we will see you next time.
Thank you, Joy.
All right.